Morning again, modelers. It's another couple of days later since that previous video, and a few nice comments that people want to see what's going on with this little project. So I'll keep doing videos until you get bored. But I have noticed 5 or 6 subscribers have dropped the minute I did that last video, so maybe it's not what's needed, I don't know. Anyway, I'll keep doing it for a bit, what the heck. So what I've done is I've got an Alpicool 65 litre 12 volt fridge, and I've been running it on my power safe lead acid battery. It's a 92 amp hour lead acid battery, and I've been running it with the battery fully charged just to see how long the fridge freezer will run. It's set to 2 degrees for the refrigeration compartment and minus 12 degrees for the freezer part, and the fridge was not cold when I started, so it did run for about 45 minutes solid to bring it down to temperature. But it did do it in under an hour. It was down to minus 12. In fact, when I first set it up, the default is minus 20, and when I did it at first, it ran for 45 minutes and took the freezer compartment down to minus 20 degrees. So a very impressive fridge. The build quality is not perhaps as good as some of the others, but it's not unacceptable by any means. It's fine. So it seems like quite a good fridge, fairly quiet. So there we go. So the numbers, let me show you the numbers. So here's the fridge, power safe 92 amp. Now it's got to be 10 years old, and it was given to me because it had been declared, unfit for service anymore. But so it's it's not it's not new by any stretch of the imagination. What I did was this is where the modelling side comes in. What I did was I connected up my What's Up meter, and I usually use this just to measure the power draw of a motor setup for a model. But as you can see here, I've used it in line with the fridge just to see the state of things. And as you can see, the voltage has now dropped to 11.88, and it's drawing 3.5 amps, about 40 watts. The fridge is actually running, and this is typical of the figures. It sits between 30 and 40 watts depending on the load. I just opened the door and opened the freezer as well, so obviously there's a bit of an air change inside, which maybe has prompted it to kick off a bit harder. It had gone from minus 12 to minus 10 in that brief door opening and closing, so it's working a little bit harder. But as you can see, it's consumed 47 amp hours, and this is after 38 hours, and the voltage is still 11.88, so it was still going. It would still keep running. The cutoff on the fridge itself, it has 3 levels and will automatically cut off when the feed goes below I think it's 12, 11 and 10 or something like that, 12, 11 and 9 or something like that. But they do advise that you should never run a lead acid battery under 11 volts. So I've set the cutoff to be 11. But as you can see, oh, there we go, the fridge is just shut down, and you can see the voltage is springing back to 12 I think it was about 12.25 before it cut in. So you can see the battery has still got life in it, but I'm very conscious that you should never go below 50% of its capacity. Originally, it would have had a capacity of 92 amps, but as you can see by that bottom number on the left, you should see it after the WF. Amp hours, there we go, 47.23 amp hours. So we're at half capacity if it was new, so I'm going to terminate the test at this point. I don't want to damage the battery any further. What I wanted to know was whether this battery would drive the fridge overnight, and it's lasted 38 hours, so well and truly overnight, and into the next few days. So I'm next going to test the solar charging system and see how well that works, and it's quite a good day for it today because it's overcast. So I'm just trying to find a way of protecting the battery from any rain that may come. I may have to put up a small tent or something in the garden just to protect the battery while I set the solar panel up. But it'll be a good test. Let's see how long it takes to put 47 amp hours back into the battery. Alright, so once I've set that up, I'll do another little video of that setup and we'll see how it goes. So this is the Renogy 200 watt panel kit. Sorry, I'm having to hold the camera. And there we have the panels. These clips are a nuisance, depending on which way around you have it, but when you're opening it, it's not so bad. When you're closing it, they're a nuisance. Now what I'm going to do, it says you should not connect, you mustn't let the voltage build up before connecting the battery. So the first thing you must connect is the battery, and that's a little bit awkward to do. So I'm not sure whether this connection here should be open until you're ready, but obviously as you swing the thing into position and point it at the sun, it's going to then create voltage. The problem is that these panels, the voltage can go very high, very, very high, and that high voltage can damage the charger. So right, so in that bag there is a bag of an extension lead to extend the lead, and I've just got my leisure battery on top of the table here out in the sunshine. So what I'm going to do is connect the leisure battery via some crock leads, and I'll use my What's Up battery meter to measure how much current, volts, and eventually milliamp hours that we put back into the battery, and how long it takes to do so. Alright, back in a moment. Took a bit of time to set this all up, and the time is now 10:30, mainly because I couldn't find enough leads to to make the connections, not of the right type. It probably would have been quicker for me to actually solder up a new lead, but as you can see, it's just brightening up. The sun's not out, but it's brighter. It was raining when I was starting all this, but it's got a bit brighter now, which is good. So there's the panel. It has little legs that extend out, and you sort of point it roughly towards the sun, I think, is the object of the exercise. It has a controller underneath, which I'm not sure you'll be able to see very much, but it scrolls through temperatures and all sorts of other settings. But the important thing to look at here is my watt meter, which is showing that even in this subdued light, there's 3.5 amps coming out of that solar panel at 12.8 volts, 46 watts, and that's about what the fridge was pulling. So there we go, the sun's just getting just a little bit brighter, and you can see it suddenly shoots up to 50 watts. It'll be interesting to look at this figure when the sun is actually out fully, but if it was pulling it out at 30 watts at a duty cycle of 50%, which the fridge is not always on obviously, then it'll be interesting to see how long it takes to put it all back in. If it's putting it back in at 50 watts, will it take 38 hours to charge it? We'll have to do the numbers at the end. It's already put in 0.17 amp hours already, but that's 0.1 of an amp hour. So I think we'll check again in an hour, and that might give us an idea of what's going on. I've just got to hope it doesn't rain, because obviously this lot is all a bit exposed. So it's been a couple of hours, and in those 2 hours I've got 10 amp hours into the battery, and the weather, as you can see, is not entirely sunny. It's the clouds are scudding in front of the sun, so I think that's pretty good. So I think that's shown that the power output from the solar panel is going to cope quite nicely with a simple 30 watt fridge. We'll just have to see how it goes, whether there'll be enough to actually charge LiPos as well during the day, and the solar just top it all back up. I don't know, but we'll see. So I think that concludes the experiments with the bits and pieces that we're going to be fitting. So back to the van now, trying to figure out where I'm going to put things in the floor space. So that'll do for now, I think. It's just to give you an update of the technology I'm using. Cheers.